Hey everybody, good to see you all again, even though I can't. Glad you're here. 5, 6, integrals involving exponential and logarithmic functions, something that we've already seen and grown accustomed to working the other direction with derivatives. Very short section, not a whole lot to it. Again, just adding on to the things that we talked about. Remember the last video, 5.5, that was all about using the U substitutions. Those will not go away. We're just adding now more additional things like exponential, something to a power of x, and logarithmic, typically the natural log. So we'll get into these, and remember, we do prefer the natural log. Its derivative was the easiest. Same thing with e to the power for exponentials. Those were by far the two easiest to do. So we will break these down into two different definitions, the e and any base to a power. We'll talk about those exponential functions and what their antiderivative or integrals are, and then we will move on to the logarithmic as well. And that's it. Now, of course, there will be more things involved, like other functions inside of these. So instead of e to the x, it could be e to the 2x, things of that nature that we'll have to deal with by using those u substitutions to rewrite them and ultimately get them into these preferred forms. So without further ado, let me give you the definition. Actually, you know what? Why don't you try to fill out that first one, 5.61 part A. What is the antiderivative of e to the x dx? Go ahead and give it a shot. Now, I asked you to try this one on your own because it is by far the easiest, no pun intended, that when we have e to a power of x, and then we have the derivative, no u sub needed, we know that the derivative of e to the x is just e to the x dx, of course. So the antiderivative of e to the x dx is just simply itself plus that possible constant. Now, any other base other than e is not as easy because if you remember those and taking the derivative of those, they had a chain attached to do the derivative of a. It required the natural log of that a. So this one, I don't expect you to remember because we didn't use it as much for the derivative, but this one would look very similar with the exception of instead of being multiplied by the natural log of a, it's going to be divided by because we're working the other direction, the inverse. So these should feel familiar. Working one direction, now we're just going again back, the inverse or reverse. So let's move on to logs. Now you'll notice there's the first one actually in this definition, 562 part A, is x to the -1, or better known as 1 over x dx. Now, should you know what originally we would have had, that when we took the derivative, we got that, because that's all the antiderivative or integration is working backwards, thinking what original function would we have had that when we took the derivative of it, gave us this. Can you fill in that blank? I hope so, and I hope you realize why it was in this part of the definition. We should know that the natural log of that thing, again, due to restrictions, we got to make sure that that comes out a positive, but because it's the indefinite integral, we'll have the possibility of a constant having been there before we took the derivative of this thing to get that. Easy way to always check, remember, if you're telling me the antiderivative is this, then just take the derivative to see if that's what you had originally before you applied that rule. All right, now, what if we were given that, the natural log of x dx? What would we have originally had that gave us a natural log of x dx? And that's not obvious. That's not one that I expect you to know, and therefore, if the easier base is e with the natural log, then when we have any other, again, that's greater than 0 and not 1, then these are going to look a little bit nasty. And so I'm just going to give you these ones for our notes. Hopefully we don't come across these. We're not going to have to use a U-sub or anything else. These are what are called definitions, which therefore means if you see this or that, which are the same, then you can replace it with that. It's already been proven. It's defined this way, and therefore this and this also, when you see it, you can look it up or memorize it and write down. Not something that we prefer to see or have had even when we were taking this and doing the derivative, because this therefore would have been a product rule, or even if you distributed it, you would still have a product between these two, and then that you could just take the derivative of. Not very nice, and hopefully you saw or are seeing a pattern with E's and A's as our bases. The only thing that's going to be different with the E base versus the any other is that it'll have that attached natural log of that base. When we're doing the antiderivative, be divided. You guys remember the other ones when we were differentiating. So what's the only difference between this answer for that and the answer for this one? It's that same thing, but going to have that divided by the natural log of A, just like we had here with the different bases. So the good news is this is probably the shortest section that we have had a video on. Very short indeed. There's not a whole lot to add in addition to what we've already learned, but of course there will be some U-sub stuff that we could have rather than just 1 over x. It could be 1 over 2x. Okay, it could be 1 over sine x. Things of that nature that we will have to then play with a little bit more with the previous section, 5.5, using our U-subs. Almost done, one more section left. And again, it is more definition based. That 5.5 still very, very important for us to be able to move forward. It's like once we learn the chain rule in chapter 3, when we're learning all the different differentiation rules, we saw the chain rule throughout. All the other definitions, we could now sprinkle that in there. Same idea here. We're just going to keep adding a few more definitions on top of that now called U-sub chain rule in reverse. All right, that's it. Let's go practice. I'll see you at the next one.